Hi, this is Jolting Jonathan with Mad Science of Southern Massachusetts and Rhode Island. Thank you for tuning in this week. We actually asked the question about some Diet Coke and some Mentos. We've all seen the reaction before. We've all seen the experiment, whether you've seen it on TV or the internet, or you've actually seen a mad scientist come to your house and do it, which is always pretty cool. We want to know what causes that reaction. You get that wonderful volcano of soda and mint. And I asked you a couple of questions. The first question was, is it because minty soda is just disgusting, the Diet Coke doesn't like the Mentos and is spitting it out? It was a silly question. I needed 3 questions. That was the first one. It's not that. 2, the artificial sweeteners mixes with the peppermint and causes a violent reaction. Not really. There's a little bit. They're not so sure about it, but possibly. Or 3, little dimples all over the Mentos actually cause this great buildup of pressure, and kaboom, it goes flying out the top. Well, actually, yeah, that's what it is. Now, a Mento, I've got some Mentos right here. You know, I've got more dumped in my cup right here. But as you can see, it looks, and we've all seen Mentos, they look perfectly smooth. They're not. The Mentos actually have all these little teeny tiny holes all over them, all over, kind of like a golf ball. These little dimples, and they're actually what scientists call nucleation points. And what a nucleation point is, have you ever gotten a soda, you've gone out to eat, and you get a soda, and you put a straw in it, and the straw keeps rising out, and you push the straw back in, and the straw keeps rising out, and it comes, and you look, and there are all these bubbles over it. That's because everything around us has nucleation points. They're little holes that attract the carbon dioxide molecules, especially in sodas and seltzer water and everything. And I want to show you a little bit more about the nucleation points and tell you what, if you watch all through it, I'm going to make this go kaboom in a little bit, all right? So what we've got is I've got a bunch of different substances here. I've got some Mentos, and I also have a spoon because I want to show you about nucleation points, and I can do it even with a spoon. So first off, we've got a container full of just water. This is just regular old tap water. What I'm going to do is I'm going to stick the spoon in there. Not a lot happens. As a matter of fact, nothing happens because there's no carbon dioxide. There are no nucleation points. If I take a Mento and drop it in there, is anything going to happen? No. There's no carbon dioxide for it to be attracted to. Now, I'm going to take a little bit of this seltzer water. We're going to pour it in here. Right up to about there. Now, if you look really closely when I put the spoon in there, see all those bubbles all over the back of the spoon? Those are nucleation points. That carbon dioxide is getting attracted right to those little points. What do we think is going to happen when I drop the Mentos in? Let's drop some Mentos in and find out. We definitely get a reaction. We definitely do. All right, let's try some Sprite. We're not going to use just as much Sprite because your nucleation points, they don't show up as well. There are some, but they really don't show up as well. But what's going to happen when I drop the Mentos in? Let's find out. What do you think is going to happen? Yeah, there's some reaction, but there's not really a lot of a reaction. All right, let's try some Mountain Dew. Do we think we're going to get a lot of reaction? I don't know. Let's find out. 2 Mentos. Not a lot of reaction. See, there's a lot of discrepancy right now about what causes the reaction. They know that it's the carbon dioxide molecules and the nucleation points, but sugary sodas don't seem to work. And right now there's a big debate among scientists. And I'm going to be honest, we don't know. We've got our regular Coca-Cola. It's got sugar. Do we think it's going to have some nucleation points? Not much at all. Because a lot of people think that sugar is actually too dense and it won't allow for that formation of the bubbles. You see, you get a little bit after a while, but it's not a lot. Some people actually think it's the artificial sweeteners that do it. And like I said, scientists, they're kind of arguing amongst themselves over whether it is. But here we go with the Diet Coke. This is the one we've all seen. I've got my Mentos. What do we think is going to happen? I'm just going to drop 2 Mentos right in there. We get a pretty decent reaction. It starts to go. Now, I know what you guys want to see. We've seen it with all these different substances, and some of them are still actually even bubbling. There's still some nucleation points on there, but I know that you guys want to see this big bottle with this entire pack of Mentos. So, tell you what, why don't we go outside? Let's launch some soda. Sound good to you guys? I'll meet you outside in just a second. All right, we know you guys want to see it, Diet Coke and Mentos. I've got my bottle of Diet Coke. I've got my Mentos. I put them in a little container just to make it easier to pour them in. It's really hard to pour them in from that little paper container that they come in. If you decide you want to try it at home, because I know you guys are going to want to try this at home, and this is one of the few experiments we do here at Mad Science that you can try at home, just go outside the home to do it. All we're going to do, we're going to open the top up, we're going to dump the Mentos in, then we're going to get the heck out of the way. That's the most important thing to remember. Let's take the top off. Like so.
business card over that just so I can get them all in there at once, and then we're going to run. Sound good, guys? And there we have it. Just because of all those little nucleation points, we got that wonderful volcano of soda. Thanks for tuning in. Tune in again. We're going to have more questions, more answers, and if you have something you want to find out the answer to, write it in. Let us know. Take care, guys.